This video gives us a brief introduction to the idea of geometric sequences. So what are geometric sequences? Well, like the name suggests, they're a sequence of numbers, and the geometric part specifically means that successive terms in the sequence have a common ratio, which we often denote by the letter R. Successive terms having a common ratio, that just means to get from one term to the next, we're going to multiply by some common number. So you can see on the example on the left here, we've got 1, 2, 4, 8 and 16 are our numbers in the sequence, and so on. To get from the first to the second, you can see there that we've multiplied by 2. 1 times 2 is 2. And you can see the same thing again. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 will give us 16. So the next term along, if we multiplied by 2, would be 32, and so on. On the right, we've got another example of a geometric sequence. Looks a bit different. The terms are 100, 10, 1, 1/10, and so on. This time the numbers are actually getting smaller, so what we're doing here is multiplying by a number less than 1. So multiplying by 1/10, or if you like, dividing by 10, but the same thing. So 100 divided by 10, or 100 multiplied by a 10th, is 10. 10 multiplied by a 10th gives us 1. 1 multiplied by 1/10 gives us 1/10. And multiplying that by 1/10 would give us 1 on 100. And so on for the rest of the terms in the sequence. So this example, we've got the numbers 5, 25, 125, and 625, and it goes on. And we're told that that's a geometric sequence. And what we're being asked to do is find what the common ratio is, and then what the next term is. So I can pick any that I like, but I'll just go with the first two numbers, 5 and 25. The common ratio is just what we have to multiply by to get from one term to the next. So you can see there that 5 times 5 is 25, so R is equal to 25. You could also do it, if you like, just by dividing successive terms. 25 on 5 is 5, 125 on 25 is equal to 5, and so on. It's always going to be the same number. That's what defines a geometric sequence. For part B, what is the next term? Well, we've got that term number 4. I'll use that T subscript 4 notation, is 625. The next term along would be term 5. Well, in a geometric sequence, we just multiply the term we have multiplied by the common ratio. Okay, so that's going to be 3,125 is term number 5. And you can keep doing that for all the terms that you want to find after that successively. We can find some rules, general rules for terms in geometric sequences. So because we use that fact that the successive terms share a common ratio R, just like we did in the part B of the previous example, we can write a rule that gives us the nth term. The nth term is the common ratio R multiplied by the n minus 1, or previous term, to the one we're looking for. Okay, so for example, here R is equal to 3. 2 times 3 is 6. 6 times 3 is 18, and so on. Term number 4 there we see is 54. So term number 5 would be the common ratio R multiplied by term number 4, which is 3 multiplied by 54 in this case. And that's going to be 162, I think. Yep, cool. So that's finding the successive terms using that sort of recursive notation rule there. We can also find a more general form of a rule. Okay, so let's take a sequence where we have that the first term is equal to A. I'm just going to call it A. You could also call it T0 if you like. Term 2 then, because it's a geometric sequence, we'd multiply by R. Term 3, we multiply by R again and get R squared, AR squared for term 3. Term 4 is going to be AR squared times R again, or AR cubed. Term 5 would be AR cubed times R, or A times R to the 4. And notice that in each case, the term we're looking at, number 3, and the index differ by 1. 3 to 2, 4 to 3, 5 to 4, and it'd go on down the line. So term n then would be equal to A times R to the n minus 1. The term number we're looking for, and the index differing by 1. So let's use that in this example on the right. We've got a sequence 5, minus 10, 20, minus 40, and so on. Now this one looks way different from what we're used to, and that's because here the common ratio is actually a negative number. It's r is equal to minus 2. And you can do that again by dividing terms, or just by looking at what you need to multiply to get from term to term. Okay, so check that if you're not sure what I'm doing there. Part A says, what is term 5? So we have term number 4. Now term number 4 is minus 40. Actually, I'm not going to do it like that, of course. I'm going to use my more general rule. So term number 5, using the rule that we've just found over here, is going to be A multiplied by r to the 5 minus 1, or 4. A is the first one, that's 5. R to the 4, that's going to be minus 2 to the 4th power, which is 5 multiplied by 2, 4, 8, 16. And 5 times 16 is going to be 80. So our 5th term here is 80. You can check that if you like, just by applying the common ratio to the 4th term. Minus 40 times minus 2 is 80. So it works out. What about term 10? Okay, now this one's a bit more useful to bring in this rule, this general rule, because we don't want to figure out all the terms in between. T10 is going to be A multiplied by r to the 10 minus 1, or r to the 9, which is 5 multiplied by minus 2 to the 9. So it's going to be 5 multiplied by 2, 4, 8, 16, 32, 64, 128, 256, 512 minus 512 is minus 2 to the 9th power. And if we multiply that by 5, we should get minus 2,560 for our 10th term. Okay, so there we go. That's a little bit about geometric sequences. Sequences are numbers where each successive term in the sequence is found by multiplying by a common ratio. Okay, we've got a couple of rules there for figuring out the terms in those sequences.